maybe the water molecule is going to come out from the soil, right? We need to create that environment, the closed environment, and using vacuum we can able to extract water molecule as well as voids, air molecule inside the soil, so that the soil is going to compile, the earth is going to compile. So that is vacuum consolidation. Preloading technique, easy technique. We have to apply some load for prolonged period. It, only one disadvantage about this method we need to wait for a longer period. If I am having a land and it need to be, I need to construct something after 5 years or after 10 years. So such kind of situation we can go for this preloading. Some load need to be placed on the land. Due to that load, it is going to consolidate. It is very good technique, but only one disadvantage, which is biggest disadvantage, is time consumption. But a solution is there for this. A solution is there. We can combine vertical drain as well as preloading technique. If we are using this both technique, few months we can able to get that consolidated soil. Okay, so vertical drains are nothing but, yeah, making bore holes. Okay, it's a drain, it's a drain, right? Bore holes. And when we are applying the load on the surface, due to the load, the water may be accumulated inside the vertical drains, and that from that vertical drains we can able to pump out the water somewhere. Okay, so this, when we are comparing the preloading technique as well as this vertical drain technique, we can able to consolidate the soil, compress the soil in little bit fast manner. Maybe within 1 year we can able to get those things. Otherwise, simply using this method may take 4 5 years of time. But vertical drain, maybe few months, maybe 1 year, we can able to consolidate. We can able to get the same result. It is depend upon the types of soil. Ground freezing technique only used in the cold weather region. Okay, by using refrigerator, if we are freezing the land, yeah, simultaneously the strength, the load carrying capacity is going to increase. If the water molecule inside the soil particle if get freezed, then yeah, we can able to get the strong bond. The water molecule may bind, the water molecule may be bind. Okay, the ice particle may be act as a binder of soil particle. It is going to bind together, right? So this is a very good method, but we can able to use only in the cold region. In the hot region means time consuming, and it is going to defreeze. Okay, so soil nailing. Most of the mountain, hilly road region, tunnels, you can see this method, which is one of the best method. Or a tunnel, maybe in the hilly road, you can see this method, right? The nails, the nails may be placed in the same interval. Okay, and I think I'm having a video. So this is the nail. Okay, previously they simply make a bore hole and they inserting the nails on it. So after this process, mesh is made all through the weak areas. Okay, all through the areas. Normally they will weld the nail and this grit together, then it get shotcreted. Simply by imagination, imagining itself, you can know how much strong is going to be. Entirely, we can avoid the landslide. Okay, so this is the soil nailing technique. Next method, geosynthesis. Geosynthesis are very good. Synthetic materials are good. So simply laying geosynthetic material, okay, we can able to. This is going to act as a reinforcement, so that once again avoid we can avoid landsliding. We can able to improve the uh, load carrying capacity of the soil, and it is a mesh kind of thing. It is having holes, so that it can be used for drainage purpose also. Geotextile, this is named as geotextile. You can see a seepage. The seepage is forming due to the retaining the structure. Yeah, the seepage get protected by using geosynthetic materials. Not only for that, we are using geosynthesis for many things. Geosynthetic for many things. Nothing. He's just going. The soil is so soft, so he's going to move his vehicle. You can see how much the soft soil they have. The soil is so soft and it is having more water on it. So then They are simply laying the geosynthetic material. That is good, right? Geogrid, just an experiment without geogrid as well as with the geogrid. Yeah, that is the best way to strengthen the soil, to reinforce the soil. Geomembrane, which we have already seen, like the seepage related thing, right? Used to store the water normally. And the geoshell, this kind of geoshell, mostly they are using in the uh, four lane construction. Where there is a bridge, you can see those geoshell material they are using. Four lane construction, bridge construction, like you can see it. Usually it is in black in color. Combination of two geosynthetic as well as clay liner. Okay. So another one is geofoam techniques. By using this foam geofoam blocks, we can able to construct the road. We can able to strengthen the road. So it is having many usage. So I'm here. Another video for you. usage of foam, geofoam, geopipe, normally for drainage purpose, composite material, a combination of fiber sheet as well as uh, geotextile materials, and these are all the material under geosynthesis, synthetic. Next technique is soil reinforcement. So this is the engineering structure, right? It was the existing soil, maybe backfill, and this is the engineering structure. Normally, soil reinforcement are used in the embankments, apartments, and hilly roads construction. Okay, so these are all the components. You can see the examples of those things. Facing material. Okay, uh, this is reinforcing materials, right? Soil reinforcement material. It may be sheet, it may be a strip, it may be anything. Here it is: strip, sheet, grid. Yeah, blasting techniques. When there is a blast, vibration creates. Due to that vibration, the soil may get compacted. So that is blasting technique. We can go up to 40 meters depth. Wet soil mixing. Wet soil mixing. Yeah, when we are combining soil with the water, it get densified, right? We can able to compact it. So that is wet soil mixing. That's all about physical technique. Next we are moving to the chemical technique, ground improvement technique. Addition of lime, cement, sulfate, gypsum, fly ash, or desalination. Addition of lime, this is called as lime stabilization. It based upon the design, the soil as well as lime may be together in a certain ratio. It is simply based on the design and type of soil and what is the locality it going to be. So it will be laid down. You know the properties of lime. Yeah, it is going. It's a binder. It is going to bind with soil particles so that the load carrying capacity is going to increase. Okay, that is under lime stabilization, and this is very good for clay soil. When where the groundwater level is more, then this kind of stabilization, lime stabilization, is very good, but it is not going to work in the sandy soil. Okay, sandy soil lime stabilization is not going to give that much result, but very good in waterlogged areas, uh, wet soils as well as clay soils. Cement stabilization, you can assume that mixing soil with the cement, you simply know about it, how the load carrying capacity is going to increase, right? Very good, very strong, and so on. But major drawback in this both method, lime stabilization and cement stabilization, major drawback வந்து curing time. Maybe during the curing period we can expect more crack on it, because we are not going to do the curing, right? We are not going to uh, supply water for curing purpose, so there will be more cracks are expected. So that is the biggest disadvantage of this both method. With the chloride, yeah, the soil can be stabilized with calcium chloride. And these are all the summary. I will try to share this ppt to you all, so that yeah, you can see, you can summarize all the things. What is the technique, problem in the soil, how it can be used, and all those things are there in this 3 slides. And yeah, these are all the book I have referred. Thank you. So that's all about my presentation. Any queries? I think less than half an hour I completed. If you are having any query, just unmute yourself and ask me.
Sir, good afternoon, sir.
Good afternoon.
Sir, I'm Sandhita Chaudhary. Actually, I am researching on the field that uh, how to stabilize the marine sand that is available on the beach or something. So,
Okay, if it is a marine sand, then it is the salt content is going to be more on it. So you have to do the desalination first.
okay.
Then it can
Uh,
be stabilized.
Sir, actually, I have an idea that to use the stabilized soil in the retaining wall as a backfill material.
Okay.
So, is this going to work or
So
like?
whether I am clear about that, whether you are going to use the that particular soil in the backfilling,
Yeah, yeah, sir.
um, yeah, it will work.
So actually, I have some material like waste material I have used to strengthen the soil, like GGBS, and I have already replaced the soil in 20% and 30% with the GGBS, and find out a good result. What like their dry density is like 2 kilonewton per meter cube, but sir, I don't think like such whenever there will be such I think it may collapse or is. Hello.
Sorry, there is a power failure in my system. So in my place. Yeah. So if it is a salty soil and the main problem about the salty soil is about the corrosion, you should not
Okay.
use any steel material on it. If it is simply backfilling, then there is no problem on it.
Okay, sir.
But there will be a leaching effect during the rainy season. But just think about it.
Okay, okay.
Yeah.
Thank you, sir.
Thank you. Any other questions?
Sir,
Any
I
other?
have one question.
Please, sir.
Sir, if you are using lime stabilization and cement stabilization,
Sir,
how will it affect the quality of drinking water in that area?
affecting
Quality of drinking water.
drinking water. Yes, sir.
Will it
That is,
affect?
it is a issue only, sir. Maybe, but sir, once the cement get hardened in a particular place only, we are going to use it. Is we are not going to cover with the entire places. Okay, it may not pollute the groundwater source, sir. Once it get hardened means, once it get hardened, then it is not going to pollute the water. It may be cement or lime. Whether I answered correct, whether you got my point, sir?
Yes, I got your point.
Yes, sir.
Sir, so you mean to say that it is very safe regarding the quality of groundwater?
Yes, sir. I'm very. My point of thinking is little bit different. We should not. We need to keep the nature as it is. Engineers, what we are doing, we are just saying to give some more property to it. Always, it is going to affect the nature only. It may be direct or indirect. So, if we are using lime, if we are using cement, it's a chemical only. It is not a natural product. So there will be some kind of indirect effect only, but it is not going to directly affect the water.
Okay, sir. Thank you.
Yes, sir.
Any other participants have any queries, you can ask, sir. So shall I wind up, sir?
Yes, ma'am.
Even though it's a noon, you made all of us to stay awake, brisk, and active, sir. Thank you so much, sir.
Thank you, ma'am.
Thank you, sir.
So,
Thank you
thank,
so.
thank
Thank.
you, ma'am. Thank you for all participants as well as Suresh, sir. Okay, for this invite. And thanks for your institution, your team, as well as your management for this opportunity to me to give. Thank you all.
Thank you so much, sir. Thank you, participants. The feedback link is available in the chat box. You can use it. Thank you.